All right, what's up, party people? We are going into test review for Unit 5, Forces that Change the Earth. So let's dive right in. We have convergent boundary. Remember, convergent means coming together, and converging happens to be a destructive boundary. So when we have one plate and another plate, when they come together, they go, the most dense plate will subduct, and as it subducts, the mantle recycles that. So it destroys that plate. So that's what happens when you have a convergent boundary. But there's three things in particular that you need to make note of. First of all, is that there is subduction, number one. And at that subduction point, the deep part that is opening up as it goes down, that's called a trench. And then as it's going down, it allows that crumpling to happen and the magma to rise, and it turns that mountain range into a volcanic mountain range. So you have STVs, subduction, trenches, volcanoes at a convergent boundary. So we're going to be jumping all around here, so hang on, stay with me. Weathering. We have weathering, erosion, and deposition. Remember that weathering breaks it down, erosion moves it, and deposition deposits it or drops it somewhere. That's a review. Don't forget that. And then also when you're looking at satellite pictures, that weathering will flatten contour lines. So if you have a steep mountain, over time with the wind and everything blowing against it, that will kind of flatten it off and it will be deposited on the other side of that mountain. So weathering flattens contour lines. Don't forget force equals mass times acceleration. You're going to need that formula for a question on this. Counting elements and atoms in a question T-chart. Don't forget that we use, when you have H2O, for example, we're going to T-chart this. We have elements and atoms. So we have H and we have O. We have two H's, one O for a total of 2 elements and 3 atoms. That's just a quick little refresher. Okay, so now let's jump back into plate tectonics. So we had convergence, now we have divergence. And diverging boundaries they can happen on land and in the water, or in the bottom of the water, the ocean. So that would lead to a mid-oceanic ridge underwater. And then on land, we have a rift valley. So those are two events that can happen as your plates move apart. And we call this a constructive boundary, where land is created. But notice that Earth is not getting any bigger or smaller. So where land is being created, it's also getting destroyed elsewhere, keeping it in balance. Excuse me. So let's bounce back now. We're going to move back into convergent because there's a thing about convergent that you need to remember. Remember that there's 3 different types of convergent boundaries. There's continent, which creates really high mountains like the Himalayas. We have ocean, which you get that dense plate. Whichever plate is more dense will subduct, and that will create volcanic islands like the Aleutian Islands. And then you can have continental and oceanic, which can create for example, the Andes in South America. Don't forget about atomic structure. We have protons and neutrons in the nucleus that make up the mass, and that's a positive charge coming out of that nucleus. And then we have electrons around the outside. And if you're trying to figure out what the overall charge of the atom is, you compare electrons and protons. When we're looking at topo maps, remember that the closer the lines are for your topo map, the closer the lines are, the steeper it is. So this area would be really steep, and this area would be more flat because they're wider. Okay? And if you walk around one of the contour lines on a topo map, you will never get any higher or lower as far as sea level is concerned, because you'll be on the same elevation. and that contour lines count elevation. We have, okay, so when you're looking at a mid-ocean ridge and that magma comes up and new rocks are born at that ridge, as it moves away from that ridge, the rocks get older and older. So when you take rock core samples from the ridge, either side, you're going to find newer rocks. As you move further and further away from the ridge, you'll find older rocks. So let's go back into before plate tectonics. Let's go into continental drift. Remember, Alfred Wegener came up with 5 pieces of evidence. The first one is jigsaw puzzle continents. And then when you put those continents together, you'll notice that the fossils match up as well. So fossil evidence number 2. Number 3 is rock strata. When you match those continents up, you'll notice that the mountain structure would go across both continents. You'll find the same rocks if you take rock samples. And then we have coal in the poles. Can't forget that. Why is there coal in the poles? There's nothing really living up there. It have to be that mass moved from a place more tropical, if you will, where life could be abundant enough to create coal at that level that is up there. And then the last one is they found tropical plant fossils in the Arctic. So those are the 5 pieces of evidence that Wegener used, but he was missing one thing. What was he missing? Seafloor spreading. So they put the 5 pieces of evidence together with seafloor spreading. Voila, we have plate tectonics. And how did my Hawaiian Islands become the way they are? Not at a boundary, because they were at a hot spot. So which a hot spot is a thinning in the crust that allows that magma to come up, and as the plate moves, the islands get older and older the further you get. So the youngest island right now is the big island of Hawaii that actually keeps having lava flow. So SVA, let's look at speed, velocity, and acceleration. Make sure you understand the differences between speed, 50 miles per hour, velocity, 50 miles per hour north, and acceleration is speeding up, slowing down, or changing direction. Understand how forces can affect an object. Forces can stop an object, speed an object up, make an object turn. Unbalanced forces can make plates move. And testing strategy number 742 states that if you see unbalanced force as one of your answer choices, it's possible it's the right one. And that, my friends, is it. One last thing, magnetic reversal on the ocean floor. The epochs of time state that over time it will reverse the magnetic reversal from the poles. So that's it, guys. Good luck on your test.